Good day, everyone. We are here for presenting our research paper to our Mapua course in graduate school, IA 120, System Engineering Analysis and Design. So without further ado, let's begin. The research entitled Application of Kepner-Tregoe Approach on Evaluation of 28 Days Compressive Strength of Concrete Mixed with Waterproofing Admixture by Larry Contino Flores and Mark Alvin Paloma. The contents of this presentation includes introduction, literature review, methodology, data collection, results and discussions, and conclusion. For the first four contents, I will be discussing this one, introduction up to data collection, and the rest will be discussed by Larry Flores. For the abstract, concrete is a building material made up of aggregate, typically sand and gravel, which is hard, chemically inert particle that is cemented together with cement and water. Because of the harsh ground condition in Qatar, which include possibly high sulfate and chloride levels, as well as high groundwater level. Most concrete ready-mix used in pouring structures is commonly blended with waterproofing additive. The goal of this study is to see if adding waterproofing additive to the concrete design mix causes discrepancies in the compressive strength test results by statistically analyzing the compressive strength test data using the standard deviation. The results were analyzed using the Kepner-Tregoe approach. First, let's tackle the introduction. Qatar is a Western Asian country. It occupies the small Qatar Peninsula on the Arabian Peninsula's northeastern coast, sharing its only the land boundary to the south with Gulf Cooperation Council monarchy Saudi Arabia, with the remainder of its territory covered by the Persian Gulf. Qatar is experiencing rapid economic expansion, which can be seen in the construction and building business. Qatar has been chosen as the host country for the 2022 FIFA World Cup. Construction and renovation of 4 class stadiums, as well as major infrastructure investment, are planned, including proposal to expand an international airport, a harbor, an integrated rail network, and a metro system. As a result, a large amount of construction materials is required to keep up with the rapid industrialization and infrastructural expansion. Concrete in particular is the most important material for all building structure. In Qatar, ready-mix concrete, also known as concrete ready-mix, is major contribution to the building and development of various projects. Concrete, sometimes known as the ready-mix concrete, is a composite traction material. Concrete is an important component of construction infrastructure. Cement, water, admixture, and aggregate are used to make it. Building highways and bridges, sidewalks, and other construction can all be constructed using. In addition, in concrete ready-mix, admixture are usually added. Admixture are ingredients that are added to the concrete batch immediately before or during mixing. And admixture is defined as a material other than water, aggregate, cementitious materials, and fiber reinforcement, used as an ingredient of a cementitious mixture to modify its freshly mixed setting or hardened properties, and that is added to the batch before or during its mixing, according to the ACI Committee 212/2010. Waterproofing admixture is added on the concrete ready-mix to protect the concrete from the presence of such waterborne deleterious contaminants such as carbonates and sulfates. By evaluating the compressive strength test results statistically using the standard deviation, this study will see if adding a waterproofing admixture to a concrete design mix with a concrete grade of 40 Newton per millimeter squared will cause inconsistency in the compressive strength test result of concrete. Smith is the approved concrete ready-mix supplier of 40 Newton per mm squared for the project design and build of mixed-use buildings, Commercial Boulevard, DP18A, Lusail, Qatar, and relevant data was retrieved from the third-party laboratory, Arab Center for Engineering Studies, or ACES, responsible for concrete testing. For our objectives of this research, the primary goal of this article is to determine whether the added waterproofing admixture on the concrete design mix with a concrete grade of 14 Newton per millimeter squared will cause inconsistency in the compressive strength test result of concrete by statistically evaluating the compressive strength test results using the standard deviation and comparing them to applicable requirements of the American Concrete Institute, or ACI, and pattern construction specification, QCS 2014. Now, let's move on with the literature review. We have 4 literature review. One of these is development of high performance concrete using combination of mineral admixture. The main objective of this research is to study the performance of various combination of fly ash, silica fume, and slag silica fume concretes under 3 different curing regimes: continuous moist curing, no moist curing after demolding, and the last is the air drying after 7 days of initial moist curing. 6 different concrete mixes were prepared with ordinary Portland cement and a blend of Portland cement and combination of fly ash silica fume and slag silica cement fume. And the next is the development of high durability concrete for Arabian Gulf environment. The aim of this project is to study 4 interrelated aspects, namely the effect of hot environment on the properties of fresh concrete incorporating minerals and admixture. The next is the influence of exposure environment on the engineering properties of hardened concrete under various curing conditions without and with mineral admixture. And the third one is the difference in porosity and pore structure of the same set of mixes. And the last one is the effect of outdoor exposure on the durability related properties of the concrete. The third one for our review of related literature is the investigation and modeling the effects of waterproofing and water repellent admixture dosage on the permeability and compressive strength of concrete. In this study, the structural waterproofing products, structural water insulation application, and effects of waterproofing admixture on the concrete were experimentally investigated. Different dosages in the concrete mixture from 0% up to 2% were used to determine the effects of the chemical additive on the permeability of the concrete and the compressive strength of the chemical additives. And lastly, for our fourth literature review, is the effects of the waterproofing admixture on the compressive strength and permeability of recycled aggregate concrete. The recycling and reuse of demolished concrete aims to prevent the environment of reducing the waste disposal areas. Moreover, the replacement of virgin aggregates with aggregates obtained by crushing and concrete waste can decrease the new forest development rate. This paper investigates some properties of recycled aggregate concrete, or RAC, containing the waterproofing admixture. Concrete mixes with and without waterproofing admixture are tested in order to examine the slag, temperature, density, and air content of concrete at fresh state, and compressive strength and the permeability of concrete at hardened state. Now we proceed with the methodology. The application of system engineering on determining the effect of added waterproofing admixture on the concrete design mix, 14 Newton per millimeter squared, Kepner-Tregoe approach will be used on the evaluation of result from the following method and standard requirement. First is the standard deviation. American Concrete Institute, and the last is Qatar Construction Specification. For the standard deviation for the concrete is the method of determining the reliability between the compressive strength result of a concrete batch. The standard deviation serves as the basis for control of variability in the test result of concrete for the same batch of concrete. It is a statistical method that is based on the correlation analysis, testing of hypotheses, analysis of variance, and regression analysis to compare two or more series of compressive strength of concrete concerning their variability. In simple words, the standard deviation manifests the range of dispersion or variation in the result that exists from the mean, average, or expected value. In this study, standard deviation retrieved from the monthly test report from third-party laboratory cases will be used to plot the following data as the basis for analysis. The first is the compressive strength of 28 days, retrieved from the monthly test report for the third-party laboratory. Next is the warning line, referred to Section 3.3 Qatar Construction Specification 2014, and control line, referred to Section 3.3 Qatar Construction Specification 2014. The second one for our methodology is the American Concrete Institute. The American Concrete Institute is leading authority and resource worldwide for the development, distribution, and adoption of consensus-based standards, technical resources, educational programs, and proven expertise for individuals and organizations involved in concrete design, construction, and materials, who share a commitment pursuing the best use of concrete. To conform to the requirements of ACI 214R02. The strength test representing the concrete must meet the following requirements. First is the average of any three consecutive strength tests shall be equal to or greater than the specific strength. The second requirement is when the specified strength is greater than 35 megapascal, no individual strength test or average of two specimen tests shall be less than 0.9 of the specified strength. And for our third methodology is in the Qatar Construction Specification 2014. QCS 2014 is a mandatory Qatari technical regulation which is followed in the construction sector. The purpose of the technical regulation is to provide technical guidance in connection with the execution of construction in the state of Qatar. Such guidance includes the establishment of the minimum acceptable material quality and workmanship for that kind of work, which is commonly occurred in the engineered projects in the state of Qatar. The specific QCS 2014 requirements the researcher has considered can be found in Section 5, Part 6, Clause 6.8.4, Item 2, stating the contractor shall provide in his analysis the mean strength, calculated standard deviation, the normal distribution of concrete strength, and the frequencies per drop. The contractor shall draw the upper and lower lines for warning line. Target mean strength plus or minus 2 times the standard deviation. And control line is target mean strength plus minus 3 times the standard deviation. Now we proceed with the data collection. The researchers use a report that presented of the Arab Center for the Engineering Studies, carried out for the quality control and laboratory testing of concrete, used for the project design and build of mixed-use buildings, Commercial Boulevard, BP 18, Lusail, Qatar, during the year 2020. The Arab Center for Engineering Studies, ACES, is a third-party laboratory in charge of material testing, and Smith is the authorized concrete ready-mix supplier of 40 Newton per millimeter squared, OPC plus GGBS plus WP.
Hello everyone, my name is Larry Condino Flores. Now we are about to discuss the results and the discussion. The compressive strength test results and standard deviation of 28 days old concrete are shown below. Concrete acquires its greatest strength on the 28th day, unless otherwise specified in the building papers. The specified compressive strength shall be based on the 28-day test results according to Section 19.2.1.3 of American Concrete Institute 318-19. The numerical results are as follows. Corresponding concrete compressive strength results tested on varying months are shown on the following tables. Table 1 shows the 28 days cube compressive strength test result and standard deviation for concrete casted on March 2020. It shows the number of samples, cube IDs, the casted structures, casting date, final average compressive strength for 28 days, and the standard deviation retrieved from the third-party laboratory. Succeeding tables shows the 28 days cube compressive strength test results and standard deviation for concrete casted on month of April, casted on month of May, casted on June 2020, casted on July 2020, and concrete casted on August 2020. Let us now discuss the graphical results. The compressive strength test results are plotted. The following figures is a chart in which the results of all strength tests are plotted consecutively. The line, which represents the specified strength Fc equals 40 Newton per square millimeter, is plotted, and the line representing the second requirement according to American Concrete Institute 214R-02 is 36 Newton per square millimeter, is also plotted. Now let us discuss the graphical results. The compressive strength test results are plotted. The following figures is a chart in which the results of all strength tests are plotted consecutively. The line which represents the specified strength, Fc, is equal to 40 Newton per square millimeter, is plotted, and the line representing the second requirement according to ACI 214R-02 is 36 Newton per square millimeter, is also plotted. The line which represents the warning line, which is equal to target mean strength plus minus 2 times the standard deviation, and control line, which is equal to target mean strength plus minus 3 times standard deviation, are plotted according to Qatar Construction Specification or QCS 2014. The target mean strength for concrete above 35 megapascal is the higher value computed from the following equations, whereas SS stands for sample standard deviation and FC stands for specified compressive strength. There are proposed improvements on this study because the above mentioned table and graph shows that the concrete samples met the required concrete strength, and that the added waterproofing admixture had no negative effect on concrete performance. The research can be improved by providing more samples. Further research can be conducted by taking into account the performance of concrete casted over a full year. This study concentrated on a single source of concrete supply. However, the researchers suggest that additional research be conducted by collecting samples from various concrete ready-mix suppliers in the state of Qatar in order to compare results and analyze the effect of added waterproofing admixture. Validation. When comparing the results of the compressive strength test performed in the months of June and July to the test performed in the months of March, April, May, and August, it can be seen that the final average compressive strength of 28 days concrete is beyond the warning line and control line. The compressive strength test results, on the other hand, clearly met the requirements. The following table compares and validates compressive strength test results at 28 days of age. The table shows the casting dates, the concrete strength requirement, which is 40 Newton per square millimeter, and the minimum and maximum concrete strength recorded. It further shows that the recorded minimum concrete strength and the maximum concrete strength complied the requirement. Situational analysis. The additive considered in this study was waterproofing additive, which blocks the capillaries and pores in concrete. It has advantages such as improving concrete water impermeability, increasing concrete durability, and preventing sulfate and carbonation ingress. Waterproofing admixture is heavily reliant on the concrete. Problem analysis. Because the waterproofing additive is highly dependent on the concrete itself, the expected concrete performance must be met. Several samples were collected and tested, and the results were analyzed using the standard deviation. Figures 2 to 7 shows that the concrete tested in June and July falls outside the positive warning line and the positive control line. Table 7 show how these results were checked and validated for compliance. Decision analysis. According to the analysis shown in tables 1 to 6 and figures 2 to 7, the concrete compressive strength test results satisfy the requirements of ACI 214R-02 and QCS 2014, which are analyzed through standard deviation for concrete grade 40 Newton per square millimeter with added OPC, GGBS, and waterproofing admixture. As a result, the researchers can conclude that the added waterproofing admixture had no negative impact on the performance of concrete, and the objective of this study has been met. Thank you very much. This is Larry Condino Flores on behalf of Mark Alvin Montino. Thank you.